1977, Charles and Ray Eames, two legendary architectural designers, produced a short video, 9 minutes long, called The Powers of 10. What does it mean? How your point of view on reality changes when you move out from your comfort zone, and either you blow it up and you look at the stars, or you look inside to look for the fine print of matters. I mean, it's fantastic. And it's available. Look at it, enjoy it, and you will learn a lot. Today, we zoom in. And we know that when you zoom in and look closer, actually reality is not as it seems. The Greek philosophers knew already they were unsupported by technology, but they had a clear view. And so they realized that nature was made out of building blocks that are called atoms. Atomic system means unbreakable system, but we know that this is not the way. It looks like a Chinese box system or a Matryoshka dolls. As you look more and more inside, you see more things. So we know that atoms are not only built out of elementary components, but they are not really a small solar system. They are somehow made in a different ways. But we know that actually you have components inside. And you know the nature of this atomic system is actually unbreakable. And it lasts forever. Not all of the elements are actually stable. There are some of them that are not. It may take microsecond, nanosecond, half a lifetime of the universe, but some of them do decay. When the atomic system decay, they actually emit some of their components. It can be gamma rays, that is to say energetic life. It can be neutrons, the small part of the nucleus, the core of the atoms, the electrically neutrons, or they can also emit, say, antimatter. So this is called radioactivity. Radioactivity is usually perceived with a sense of discomfort, but this is not the case if you think that clean energy may be produced thanks to radioactivity, either breaking up nuclei or fusing light nuclei that release energy. Also, when you're talking about medical applications, there's a lot that is really beneficial to us. Whether it is diagnostics, where you exploit the properties of antimatter, you use fluorine-18 FDG, which is emitting positrons, counterpart of the electron made of antimatter, or also when you do radiotherapy. Radiotherapy is based on radioactivity. However, this is not always the case. There are some of the elements that are really something that you don't want to mess up, like plutonium. Plutonium is used for building weapons, and the most dangerous weapons that you can imagine. So you want to see whether there's somebody or someone which is trying really to smuggle plutonium across the borders and made an illicit trafficking of it. So how do you do it? First, you have to see particles. So how can you see something that your eyes cannot? Now we know that the CERN, you know that in the big labs, we have been able to produce electronic eyes that really are able to see what our eyes cannot see. These are the particle detectors. There are several kinds of sophisticated particle detectors that can image, they can tell you actually how many of them there are, and you have also detectors that can really tell you when events occur. And then it can tell you not only that there's somebody knocking at the door, they can tell you who is knocking at the door. This is absolutely essential, because if you want to be able to spot plutonium, you have to be able to tell not only the radioactivity is there, you have to be able to tell who is knocking at the door. Now, among these little instruments, there are some that are fantastic. This block that you see here is the baseline of being able to tell who is knocking at the door. This is a brick of what is called a scintillating material. That is to say, material that is turning the energy deposited by subatomic particles into visible light. Now, depending on who is knocking at the door, the light is emitted in a different way. If the energy deposition is thin as air, then the light is emitted really sharply. If on the other end it is thick as honey, then you emit more light and is really more gentle and slow. This is light emission, but however you have to be able to record light. It is not like a bright sunny day. You're emitting a spot of quantum of light, which are called photons. And this is what is making the situation really difficult. How can you see photons? By the way, our own eyes cannot see single photons. You need something special. You need something like what you see in there. Inside here, in this little disk, you see something which is mirror-like. In the mirror-like surface, you have, think of a mosquito eye, something that looks like a mosquito eyes. And these thousands of eyelets are actually blinking whenever single photon comes in. These are called silicon photomultiplier. I mean, the master in producing this technology that was born in the research field is Hamamatsu. And this is the base of systems that are used also to identify plutonium. You can see the device in here. You can see it embedded into this little barrel, black and red. What you have in there is one of these coupled to the scintillator, which is actually showing that something is happening, and it is happening by now. What you see on the display here are actually signals that are telling you when one of these particles is hitting the scintillator, which is emitting light, which is detected by a silicon photomultiplier. The shape of the signal is telling whether it is an electron or whether it is a neutron. And then data comes. We process the data and we build up algorithms that are allowing you then to analyze the data that we collect and to tell who is who. And this is something that you see in here. This is the energy corresponding to the amount that is deposited in the particle. And this is the algorithm that we built up that is telling you that what you see in here is not dangerous. It may be the leftover of a radioactive waste or what radioactivity is used in the hospital. What you see in there is telling you that a neutron emitted, and neutron is the signature of plutonium. All this is made for agents. This is made for customs. This is made for scientists. This is made starting by the state-of-the-art technology, silicon photomultiplier by Hamamatsu.